Hello all, in this video we will talk something about the condition for similar triangle. That means we are going to find some way to prove that two triangles are similar. It's a little bit different from the congruent triangle because for congruent triangle we are only consider three conditions. In case similar, it's also free conditional, but the free conditional is a little bit different from the congruence is because for congruence we only know the size or of angle and the length of the side is are equal, is okay. But this time for similar triangle, I will accept proportion is also okay here for similar. So now let's look at that one. For number one, AAA is not difficult to understand. This one must be similar because the angle will control all the shape of the figure. So if they have three same size of angles, I think that the shape is fixed. So this one is the way that we call them similar. For part 2, you will see the three sides proportional. These two must be similar also because we know that if all the sides are in the same proportion, for example, this is 1 to 2, this one is 1 to 2, this one is 2 to 4, this one is 3 to 6. I think that the shape is similar. I just make it bigger, just like enlargement. We every time we times 2 for this triangle, so we will have the same figure. So this one is also similar. So these two I think is not difficult. But for the last one, this is called the ratio of two sides include angle. Include angle in Chinese, I've told you last time, this one is called 夾角. And you know the ratio of two sides must be linked to the angle that we are consider. So we will have the same size of the angle and we will have the proportion that two sides are equal. It's a little bit difficult to understand if I draw in two triangles. But if I draw it in the same triangle and I put it overlap here and put the B and Y in the same point, so you will see the angle is overlap. And luckily, if we know that the proportion of AB over XY and CB over ZY is equal, you will see these two lines, AC and XZ, will become parallel. I will draw it and I will try in the concept of the similar triangle in another video or the last video I've told you. So make sure that you know the meaning of it. If they know the parallel, so obviously we can say these two angles is corresponding angle. Once again, so this is corresponding angle. So this is another kind of AAA. So we will use the ratio of two sides include angle. We will not waste time to prove that they are parallel. So we will use the ratio of two sides include angle directly. So this is the three reasons that we will use in similar. So let's look at the questions. Determine whether each of the following pairs of triangles are similar. If they are, give the reason. Okay, now we do the easiest one. That is question 1. We know that this one must be similar directly. Yes, because why? We know that 40 degree, 55 degree, 59 degree, and 85 degree and 85 degree, they are the same. So we can say yes, this one is A. We cannot write triangle, something is similar to triangle something, because we do not have the alphabetic name here. So we just write down the reason A. And the other one I think that is easy for you to determine is question 4. This one is three sides proportional. Why? Because we know that how can we know that they are three sides proportional? First of all, we have two triangles. The shortest size here is 4. The shortest size of the other triangle is 6. So we will match them up, 4 and 6. So this is 2 over 3. So that means we are going to find out that they all in the ratio of 2 over 3. So let's look at the second one. The second short is 5. So that the second short here is 7.5. So we use 5 over 7.5. This is 2 over 3 once again. So I'll find the longest one, 6. And the longest one is 9. So we will use 6 over 9. Once again, this is 2 over 3. So they will have the same proportional. So I think that this is yes. This is three sides proportional. Okay, we solved the problem for question 4. They are similar. Okay, now we have 2 and 3. So do it one by one. For 2, you will see this one is the include angle. But for 3, we do not have the include angle in 6 and 8. So I don't think that we have sufficient. This one is obviously no. I can say directly because we do not have the include angle here. If I know that the include angle is 78 degrees, so we can solve the problem. If not, we cannot do anything. So what can we do is that this one we have the include angle because for the length we have 1 and 2. And inside is the include angle, and from 2 and 4 this is also the include angle. So it is possible that to use ratio of two sides include angle, but we must check the ratio of them as equal. We have 1 to 2, we have 2 to 4. 2 to 4 we can divide it by 2, so this is 1 over 2 again. So I think that both of them with the ratio is 1 to 2. So I think that the answer is yes. So the answer is ratio of two sides include angle. So this is the answer for question 2. So that we know that we have 3 different kinds of it. We have AAA, we have ratio of two sides include angle, we have 3 sides proportional. In case similar, it's not difficult for proving because we can find out it directly because we know that this triangle is provided, so this one must be AAA. If I only provide all the length, I can choose this 3 sides proportional. If I give you sometimes the angle, if you give you sometimes the length, so that we may use this one. Otherwise, the other will not be the similar. Okay, so we cannot I can say it's not only similar, maybe we are not sufficient enough to prove that they are similar. Okay, now let's do question 5. In the figure, triangle RST. Okay, we write down AAA, 3 sides proportional, and also ratio of two sides include angle. If I know that this one is similar, first of all, there must be one of these. So let's look at the picture. You only have a right angle. You do not have the other 2 angle. Oh, so that I think that I will not use AAA here. And then for 3 side proportional, we must have all the length of this 2 triangles. But we do not have the length of RT and we do not have the length of XY in form 1. You can know the answer here, RT and XY in form 2. So I will not use 3 sides proportionally in form 1. I may use 3 sides proportional in form 2. So the only one way is that we use the ratio of two sides because we have the right angle with the right angle here, and we know that 2 sides are related to this angle, stick together. So we will use these 2 to do the question. So how can I show the answer? So that we write it down in triangle RST. The longer one go to the right angle and the shorter one. So that the longer one is XZY. So N triangle XZY. Let us write down the include angle first. Angle RST is equal to angle XZY. So that this one is given. So we are going to calculate the relationship between the length. So we use the shorter one, ST first. ST is the shorter one. We will use the shorter one is ZY. So the answer of this one is that XT over XSY is 6 over 15. So this is 6 over 15. This is 2 over 5, or you can say 0.4 here. That's okay. For both of them, I will think that is correct. Okay, now we will find SR over XZ. SR over ZX. I think this is ZX. So this one is 8 over 20. This is 2 over 5. So this one is 0.4. So we will find that these 2 are equal. So we can say, this one 2, because this 2 is equal. And also with the help of the include angle are equal. So we can say triangle RST is similar to triangle XZY. So this one is ratio of two sides include angle. So we can use this reason. So every time we will find 1, 2, 3, and we must conclude that these 2 are equal, so that we can write down ratio of two sides. These 2 is equal, and also the include angle. So this is the second part of question 5. Okay, and then we will go to question 6 to question 10. So let's do it one by one. For question 6, you will see this time in the figure, triangle MNP is and triangle ZYX are similar. So once again, we have 3 reasons that prove they are similar. AAA, 3 sides proportional, and finally, ratio of 2 sides include angle. So obviously you see that we only have sides here, we do not have angle. So the only one way we can choose is 3 sides proportional. This 2 is impossible because for AAA you must need the angle. For ratio of 2 sides include angle, you also have 1 angle here, but we do not have any angle here. So the only one way we can choose is 3 sides proportional. If it's possible, so that we can find out that they are 3 sides proportional. So let's look at the question one by one. In triangle MMP and triangle ZYX one by one, MMP ZYX. Okay, the longest one, the shortest one, and the middle one. The longest one, the shortest one, the middle one. So that is ZYX. Okay, now let's do it one by one. We do it from the short. The shortest one here is PN. So why don't we find out the PN first? Over XY. XY is another the shortest one in the other triangle. So that one is 5 over 3. So every time we are going to find out that are they equal to 5 over 3. Okay, now we're going to find the next. The next is the middle one. The middle one is PM over, I do not have enough space, so I write it here. You can write it here for your next step. PM over XZ, okay? XZ. So PM is 7, we over 4.2. So what can we do? We can expand it to 70 over 42. We times 10 for both sides. So we can do the cancellation. For 7, this is 10. For 7, this is 6. So once again, we can have 5 and 3. So once again, this is 5 over 3. Okay, we have 2 pair of line with the same proportion is 5 over 3. So we are going to find the last one is the longest one. The longest one is MN over ZY. So we have MN is 9, ZY is 5.4. So once again, we expand it by 10, 90 over 44, 54. We can do the cancellation. This is 10 over 6. Once again, 5 over 3. So this one is once again 5 over 3 because PN over XY is equal to PM over XZ equals MN over ZY. I think that 3 of them are equal. So we can say these 2 triangles are similar. MNP is similar to triangle ZYX. So this is one is 3 sides proportional. So we can write something like this. This is the answer of question 6. Okay, now we will do the question 7. The question 7, I think that is the easiest one to solve the problem. Because we know that for the question 7 in the figure are triangle PQR and UTS. We know that 62, 60, 48, 72, 48, 70. I think that both 2 of them will not have the same size of the angle for 3. So this one obviously, no, they are not similar. We can directly write down the answer. Because we know that all of them we do not have the same size of angle. So for question 8, this time can we say that they are not similar? I give you 15 seconds to try first. Are they similar? Okay, now I tell you, the answer is these two are similar. Because you know that we have 60, we have 70, we have 60, we have 50. We do not know the other angles, but in case we can use angle sum of triangle to find out of it, because we know that for this one is 70 and this one is luckily 50, so that we can solve the problem. So before we do this, we must find out the angle first. So why don't we find the angle? In triangle ABC, we need to find the angle. Angle ACB plus 70 degree plus 60 degree is equal to 180 degree. We must write down it. So this one is angle sum of triangle. Okay, we can do something like this. And we found the angle ACB is 50 degree. And in triangle DEF, we are going to find the angle EDF plus 50 degrees plus 60 degrees is equal to 180 degrees. So this one is angle sum of triangle. So angle EDF is equal to 70 degrees. So we know the question 8, we have two triangles here, so that we can find out these two angles so that we can prove they are similar. So now we're going to prove the similar. This is a little bit narrow, but I can try to find out write down the answer here. In triangle ABC and triangle DEF, okay? Triangle DEF. Okay, first of all, I need to write down angle ABC is equal to 60 degree is equal to angle DEF. Okay, this is given for both the angle. But the next one, we are not going to write down given because we calculate these two. So we are no need to write given here because I do not give it to you. So the answer, no need to write any reason for the second one. So for angle BAC is equal to 70 degree and equal to angle EDF. No reason here. And for the last one, angle ACB is equal to 50 degree is equal to angle DFE. Once again, no reason because I've calculated. So finally, triangle ABC is similar to triangle DEF. We can write the answer A, so we can solve the problem easily. For the question 8, okay, now for question 9, we're going to do is that once again, AAA. This one is not possible. You know that we only have one angle here. Second one, three sides proportional. Once again, we can erase it directly. We do not have the HA and we do not have the PM. So we cannot use these two. The only one we can choose is ratio of two sides include angle. Because we have two sides here, and with the two sides, we have the include angle is 48 degrees. So I think the only one that we can choose is this one. So we will follow these steps to do the question. So let's us do it one by one. In triangle JIH, okay, I used to follow this one, JIH, and triangle. That is the shortest one, go to the 48 degree, and to the longest one. The shortest one is MMP, so triangle MMP. Okay, now let's do it one by one. We found the angle first. Angle JIH is equal to 48 degrees, is equal to angle MMP. So this one is obviously given. I give it to you. So these two angles are equal. And now we're going to calculate the proportion. The proportional first is JI, the shortest one, over the shortest one is MN. So that is 8 over 12. Okay, this is calculation, so no reason is here because I do not give it to you. You are going to calculate this one is equal to 3 over 2. And next, we are going to find out is the IH over MP because we will use the two longest line to find the comparison. This is 12 over 18, so this is once again 2 over 3. So we know that JI is equal over MN is equal to IH over MP. So luckily we can say that these two triangles are similar. JIH is similar to triangle MMP. The reason is ratio of two sides include angle. Okay, so these two we can solve. Okay, now I will give you 15 seconds to do question 10 first. Which reason you are going to choose to prove that they're similar? A, three sides proportional, or ratio of two sides include angle. Okay, 15 seconds. Okay, the answer is that the only one way we can choose is three sides proportional because we have 6 length of it. But I can tell you the answer for this one is no, they are not similar. So let's show it why they are not similar. If I want to find the in triangle ABC, that means we go to shortest one to the longest one and back. So the shortest one is 8, the longest one is 14. So we will have RPQ and triangle RPQ. We write down pair of the triangle first. We use the shorter side. It's AB over RP. AB, the first two. RP, the first two. We use the shortest one, 6 and 8. So we have 6 over 8. This is 3 over 4. Okay? So we are going to find out that they have the same proportion, 3 over 4. Next is the second one is AC. Median is 9. AC here. So that we will choose RQ. RQ. This one is once again is 9 over 12. Once again, this is 3 over 4. Okay, we have 2 of this. If we have the last one, it's called BC over PQ. It's also the same 3 over 4. I can say they are three sides proportional. But unluckily, this one is 10 over 14. This is 5 over 7. This is not 3 over 4. The number of this one is, I think that is a little bit, this is 0.5, 0.71 something, but not 0.75. So they are not similar because this one is not equal to 3 over 4. So I can say triangle ABC is not similar to triangle RPQ. Okay, they're not similar. This one is the answer for the question 10. So make sure that you know all this question easily. Okay, this is the end of this video. So hope you that all of you know how to do the condition of similar triangles. Bye bye.